Chapter 1 and Chapter 2. I'm going to give you a quick overview of our three standards that are going to be in Chapter 1 and Chapter 2, and then we'll get started on our first objective. The first standard is to transfer previous Algebra 1 skills to Algebra 2 foundational concepts, and we have a number of different concepts underneath there that we will need to master in order to master this standard. Our next standard is to solve and graph absolute value equations and inequalities, and then finally to use technology to find a prediction equation and a correlation coefficient. Let's go over this first scale here because this is how you will be graded on this standard. You'll see that we have listed out all the different objectives here, and in order to achieve a level 1, you have to be able to demonstrate the following concepts. Here, you must be able to either solve equations, linear equations, one variable inequalities, solve literal equations, find slope, writing parallel and perpendicular equations, identifying x and y intercepts and graphing, graph a linear equation, functions with domain and range, and then finally graphing linear inequalities. In order to move beyond a level 1, you would need to demonstrate 5 of those concepts. Then we have 7 for a level 3, and if you can show mastery of all of those concepts, then you will earn a level 4. The first objective here, I can solve a linear equation. All of these objectives in this first standard, just like the standard suggests, should be a review for you. But we are going to go over them because I know it's been a while, at least over the summer since you've seen these. So remember, to solve an equation, we're always doing the opposite. So in the first one, we will add 5.48 to get m alone. Do it to both sides. That gets rid of this 5.48 on the left, leaving us with just m. And on the right, we have 5.5. Now I did want to take a second to show you something on your graphing calculator that you will use over and over and over again throughout the year. And that is the ability to change a decimal to a fraction. While yes, this decimal is not a very nasty decimal, and my general rule of thumb is that if there were decimals already in the equation, you may leave your answer as a decimal. However, this is a great opportunity to learn how to change that decimal to a fraction. This will also work to simplify any fractions that you have because you must always give simplest form. The reason why we require fractions in our answers from now on is because a fraction always gives us an exact answer, whereas a decimal may be rounded or may have to include other notation to give an exact answer. So all of your answers that you put on quizzes and tests, unless it already had a decimal in the answer or it told you it was okay to round, should be given in fraction form. So we had 5.5 as our answer. In order to change this to a fraction, we're going to use the Math button here. Math. And then you'll notice that the very first option is frac. That is going to change our 5.5 to a fraction. So it says 5.5, and that arrow means I'm going to change it to a fraction. And once you press enter, it automatically gives you simplest form. Let's pretend for a second that I had an equation here of 68. I was given the fraction of 68 over 4. And I know that I need to reduce that. I know that you guys have been taught how to reduce fractions. You could divide both the top and the bottom by 4 and reduce it that way. But you can always use math and frac to reduce it. Now this one, of course, reduced quite nicely. Even if you had something that didn't reduce nicely, like maybe 63 over, say, 27. You could still reduce that one by pressing Math, Frac, and it gives us a reduced fraction. So Math Frac is a very important tool that you should master from your graphing calculator. Let's move on to our next equation. This equation has 1/2 t equaling 18. Whenever you see a fraction here, the easiest thing to do is to multiply by the denominator to get rid of it. So we're going to multiply by 2 on both sides. And I get 36 equals, and I'm left with 1t. Of course, guys, you can always check your answers by plugging them back in for the variable and make sure that they're right. And I highly encourage you to do that on quizzes and tests, especially because we all make careless mistakes. As a matter of fact, when I was filling out the notes, I found a careless mistake that I made. I wrote the wrong number down when I was writing down the answer to the equation. So I really encourage you to go back on quizzes and tests and check your answers. For the next one, we now have parentheses here. In fact, 2 sets of parentheses. So we need to distribute the front number to the numbers inside of the parentheses. Now be very careful, because in this second one, we are not distributing 2 inside of these parentheses. We are distributing -2. So it may be a good idea for you to circle that negative with it to remind you as you're multiplying that it is a -2 that you are distributing. So we have 53 equals 3y, and 3 times -2 gives me -6. -2 times 3y gives me -6y. -2 times -1 gives me +2. Next, we need to combine like terms. I have a 3y and I have a -6y. Those two are able to combine together to give me -3y, and then -6 and +2 can combine together to be -4. It's a lot simpler equation now. Our next step is to do those opposites. Once we've simplified one side all the way down as far as it can, we've got to use those inverse operations to get our variable alone. So we're going to add 4 to both sides. That gives us 57 equals -3y. Divide by -3 on both sides. And my final answer becomes y equals -19. Let's take a look at number 4. For number 4, I see that I have like terms here that I can combine. -7x minus 4x gives me -11x. And over here, -2x and -8x, those will get to combine together so that I'll have 8 minus 10x. Add 10x to both sides. And I have -1x equals 8. Divide by -1 on both sides, and x is equal to -8. Just a reminder, as you're walking through these notes and you're writing down these notes as we're going through this, it's always a good idea for you to, when you think you have a handle on it, pause it and try the next problem and see what happens. It's also a good idea that if you're ever lost and you don't understand what happened, you can always pause and rewind and listen to it again. Or another idea would be to circle that problem or write your question next to that problem so that when you come in tomorrow and I ask, does anybody have any questions on yesterday's lesson, you would say, oh, I didn't understand how you did this, or can you redo this example? And it's a great way to start off our class. Let's take a look at the next problem here. We're going to distribute -8 all the way across. So I have -8 minus 32x. Here, again, if you want to, so you can circle that -8 to remind yourself. You're probably less likely to forget about it because it's all the way in front. But do what you need to do to get a correct answer. Add add 7x, and it equals negative 25 minus 8x. Next up, we are going to combine some like terms, which I have like terms on the left side here. Negative 8, and then we have negative 32x plus 7x gives me negative 25x. Negative 25x minus 8 can't combine. Whoops. That should be a 25 minus 8x. Those cannot combine because they have to both have the same variable. So my next step is to move my variables together. So I'm going to choose to add 8x to both sides. If you'd like to avoid having to deal with a negative number, you could have added 25 to both sides. So I have negative 8, and then this is still minus 17x equals negative 25. Now we're going to add 8 to both sides. And that gives me negative 17x equals negative 17. And I'm going to divide by negative 17 on both sides so that x will equal 1. Number 6, we're going to distribute a negative 1. Whenever you have just a negative hanging out in front and there's no number, it is assumed to be a negative 1. You just don't see the 1. So we're going to distribute negative 1 on the inside. And one of the most common mistakes I see from students is that they will distribute this negative 1 to the 6x, making it negative 6x. But then all of a sudden, when they distribute the negative 1 to the negative 5, they forget that it changes to positive 5. Now let's get our variables together by adding 6x to both sides. And I have negative 6x plus 6x. That cancels out. Negative 6x plus 6x, that cancels out. And we're left with this 5 equals 13, which is not a true statement. So our answer has to be no solution. If we were left with a true statement, let's say that those x's canceled out and we were left with 5 equals 5. Our answer then would be infinitely many solutions, or you could write IMS. Let's take a look at number 7. For number 7, again, I've got this negative hanging out in front, so I know that I'm distributing a negative 1 across both of those numbers. Nothing needs to happen on the left side. So I have negative 8n minus 4, though. Remember to change that sign when you distribute a negative. And still plus 2. Let's combine like terms. So I have 4 minus 7n equals negative 8n. And then we have negative 4 plus 2 gives me negative 2. Add 8 to n to both sides. So I have 4 plus n equals negative 2. I can subtract 4 from both sides, and that leaves me with just n equals negative 6. In the next problem, you might notice right off the bat here that I have 2x on one side and I have 2x on the other side. So when I go to combine those, subtract 2x, subtract 2x, I'm going to have a similar thing happen in number 8 that happened in number 6. This 2x is going to cancel, these 2x's are going to cancel, and I'm left with 12 equals 6, which once more, not a true statement. So my answer for this is no solution. And let's throw in a word problem here just for good measure. Alyssa has $40 to spend at the fair. The cost to get in is $10, and each ride that she goes on would be $1.50. She wants to know how many rides will she be able to go on. Well, we know that no matter what, even if she just walks in and watches the people, she would have to pay $10. In addition to that, she's going to have to pay $1.50, so 1.5 times the number of rides that she takes. And she has $40 to spend. So there's our equation. Our first step would be to subtract our 10 from both sides. And I have 1.5x equals 30. Divide by 1.5, divide by 1.5, so that x is equal to 20. Alyssa can go on 20 rides. All right, I may have gone kind of fast through that for you, or maybe it was too slow, but just remember this part is a review part. You can always pause, rewind, and listen again. If you're confused, you can always work through problems, skip ahead and see if you got the right answer. That's one of the benefits of being able to watch the lesson online on your own time. So now is a great time to go ahead and get your assignment out, work through those problems, and then check your answers on Schoology.